The human working memory can only hold 4 chunks of information at once. Every time you open a new tab, your hippocampus moves closer to a system crash. But what if you could build an external cerebellum?
We have pretty much all of human knowledge right here in our pockets, right? And yet, so many of us feel more scattered and forgetful than ever before. It's this really weird contradiction. We've got infinite information, but our ability to actually recall any of it feels finite and shrinking. If that sounds familiar, you're in exactly the right place. We're going to break down this paradox and, more importantly, how to solve it.
I mean, who hasn't felt this? Your brain just feels like a web browser with 100 tabs open at once, and you can practically feel your mental battery draining. That cognitive fog it's exhausting. And it makes you wonder, right? Are the very tools that are supposed to make us smarter actually breaking our brains?
And that really gets to the core of the problem, the overloaded brain. We're stuck in this crazy feedback loop. We use technology to manage the flood of information that technology itself is creating. So, is this just a trap? Are we doomed to this endless cognitive strain? Or could this technology, if we use it with a bit of intention, actually be the cure?
Well, what this all points to is something researchers are calling the digital brain paradox. You might also hear it called the paradox of resilience. And it's this fascinating and honestly critical idea that our digital world is having 2 completely opposite effects on our brains at the same time. It can either empower your brain or it can cause it to atrophy.
So you've got these 2 paths. On one side, there's the very real risk of brain atrophy. But on the other, there's the potential for incredible brain empowerment. Some amazing research from Dr. Gary Small and his team at UCLA shows this crystal clear. The exact same technology can either weaken your neural circuits or it can strengthen them. The difference, the entire pivot point between these 2 outcomes, is how we engage with it. Let's look at the scary part first, the atrophy side, because the stakes here are really high. Studies are showing that extensive, passive screen time, that endless, mindless scrolling, is linked to some serious issues. Things like heightened ADHD symptoms, even impaired social intelligence. But what's truly alarming is the biological hit, decreased brain connectivity. The actual pathways for language and cognitive control can literally get weaker. So this isn't just a feeling of brain fog, it's a measurable neurological effect.
But here's the other side of that paradox, the empowerment. And these fMRI scans from that same UCLA study show it beautifully. This is the solution right here. When people engage in intentional, complex online searching, it's like a workout for the brain. I mean, just look at the difference. The brains of these savvy users are just lighting up, hitting all these regions responsible for decision-making and complex reasoning. They are actively building a stronger, more resilient brain.
So, to really get why we're so vulnerable to this overload, we gotta look under the hood. And look, this isn't some personal failing or a lack of discipline. It's about the fundamental hardware we're all running on, our biology. It has hard limits.
This number right here, this is what defines your conscious mind. You can forget that old myth about remembering 7 things. Decades of research, really refined by cognitive scientist Nelson Cowan, confirms that our working memory, think of it like your mental RAM, can only hold about 4 chunks of information at a time. That's it. That's our biological bottleneck. Now contrast that with an AI's context window, which can hold thousands of pages of information. We are dealing with a massive hardware mismatch.
And when we try to shove more than those 4 items through that bottleneck, we hit a state of hippocampal overload. The hippocampus, which is crucial for forming new memories, basically just has a system crash. This is why you forget someone's name the second after you hear it. In our world, which is just so dense with information, an external memory system isn't a luxury anymore. It's become an evolutionary necessity. Okay, so if we need an external system, what should it actually look like? This brings us to a really powerful new way of thinking, the AI external cerebellum. Now, why the cerebellum? Think about it. The cerebellum doesn't do your conscious thinking, that's the cerebrum. No, the cerebellum coordinates, it automates, and it refines complex actions. It manages all the background load so that your conscious mind is free to focus. And that is exactly the role AI should be playing for our memory.
And to build this external cerebellum, we have to make a big shift. We need to go from passive cognitive offloading to active memory management. Offloading is just, dumping a file into a folder and just hoping you'll find it later. Active management is about building an intelligent partner that actually anticipates what you need and works alongside your biological brain.
Because the danger of just passively offloading is very, very real.
And it has a name, digital amnesia. It's this wild phenomenon where the very act of saving something makes you more likely to forget it. Your brain doesn't engage in what scientists call germane cognitive load. That's the good kind of effort, the kind that's required for learning, because it just trusts the device to do the remembering. And that leads to shallow learning and brings us right back to that risk of brain atrophy.
So does this whole active memory management thing actually work better? I mean, is there proof? Well, the data is absolutely conclusive. Recent studies on a model called a cognitive workspace produced this truly heroic number, 58.6%.
It's the memory reuse rate. An active AI cognitive workspace learns from your patterns. It connects dots. It resurfaces information for you. This means that almost 60% of the time, the information you need is presented to you before you even have to search for it. It's the difference between a dumb file cabinet and a true cognitive partner.
Okay, so this is a really powerful model, but how do we actually put it into practice? How do we build this system and get those brain-building benefits while dodging the atrophy? Well, it all comes down to 3 specific protocols you can start using today.
And let's be absolutely crystal clear about this. These protocols are the specific antidote to the digital atrophy and amnesia we've been talking about. The whole goal here is to use our technology to augment our own intelligence and free up our limited working memory, not to let our cognitive skills just wither away. So here they are. Number 1, the Active Workspace Protocol. Number 2, the Neural Circuit Trainer. And number 3, the Intentional Search Protocol. Together, these things create a complete system for building your external cerebellum and making sure your relationship with technology is one of empowerment, not dependence. Let's break them down.
First up, the Active Workspace Protocol. This is how you get that 58.6% efficiency gain. You have to stop treating your tools like a digital junkyard. For each major project you're working on, build a persistent workspace. Actively link your notes, have it summarize articles, ask your AI to find connections between ideas. You are literally training it to be your cerebellum.
Second, the Neural Circuit Trainer. This is your direct defense against digital amnesia. To counteract that shallow encoding that happens with passive offloading, you've got to strengthen your own working memory. That UCLA paper specifically recommends exercises like N-back training games. These are drills that directly target and improve that core 4+1 cognitive capacity. You're making your biological RAM stronger.
And finally, the Intentional Search Protocol. This is the antidote to that passive scrolling atrophy. It brings us right back to those fMRI scans. Remember how those brains lit up? This is how you do it. Instead of just consuming content, actively engage with it. Give yourself complex questions and use the internet to synthesize answers from multiple sources. You're turning information gathering from a passive habit into an active brain-building workout.
So this is the choice that's right in front of all of us. Our cognitive future isn't set in stone. We can either just drift into a state of digital amnesia and atrophy, or we can consciously use these protocols to build a really powerful partnership between our biological brain and our technology.
And this one idea really captures the entire strategy. The goal is not an artificial brain to do our thinking for us. No, it's an external cerebellum, a system that flawlessly handles the coordination, the organization, the retrieval, so that it amplifies our own unique human ability for creativity, deep thought, and insight.
And all of that leaves us with one final crucial question. The tools are here, the science is clear, and the protocols are actionable. The choice between atrophy and augmentation. That's a choice you get to make every single day. So, how will you architect your cognitive future?